This will be a review of sections 1.3 and 1.5 for the upcoming quiz. I'm going to go through one problem of each learning target, and we'll go over the success criteria. And then after the video, I'd like you to complete the rest of the problems and then check your work with the posted answer key. So our first section, 1.3, our first learning target, right here, I can use a piecewise defined function to model a real world problem. So we're given a story problem here, and we're going to write the piecewise defined function that describes this situation. So the first thing I want to do here is I want to read it, obviously. I'm going to read the problem, and then I'm going to highlight each piece. So the piecewise function is a function in pieces. So as I'm reading through, I'm going to highlight each scenario or each piece. So let's try that. So a cable company offers a monthly plan of $65 a month. The plan includes up to 30 channels. So right there I see that's my first scenario or my first piece. So I'm going to highlight that. $35 a month for 30 channels. $65 a month, sorry, $65 a month for 30 channels. So that's my first scenario there. So basically, it's going to cost me $65 each month. That amount is not going to change. It's just flat rate, $65, as long as I stay in from 0 to 30 channels here. So let's keep reading. And charges $3 per additional channel above the 30 included channels. So there's my second scenario, or my second piece. So if I go above 30 channels, greater than 30 channels, I still have to pay that $65, but now for each channel over the 30, I have to pay $3 per channel. So we want to write a piecewise function for f of x, the cost for the number of channels per month. So secondly, I want to figure out what is my x in this problem? What is my unknown? So what is x? In this problem, x is the number of channels. X is the number of channels. That's the variable in this problem. Okay, so I've highlighted my two pieces. I figured out x. Now I'm ready to write my answer. So we always start by doing f of x equals, and then that fancy bracket. And then in that fancy bracket, we'll write our equations with their domains. Write equations with their domains. So let's try that. That's the hard part here. So I can do my f of x equals fancy bracket. So let's reread this first scenario, $65 a month. And we said that's a flat rate. That's not going to change. It's constant. So that's just the number 65 there. I'm not going to put an x next to it because the 65 cannot change. It's only $65 a month. And then that's from, or up to 30 channels. So from 0 to 30 channels. All right, let's look at scenario 2 for my second equation. So this one, you still have to pay that $65 a month. That's a constant no matter what. But now we have to pay $3 more per each additional channel. So that's 3 times however many channels I have. But let's think about this. This $65 already pays for 30 channels, so I don't want to pay $3 for those 30 channels again. I just want to pay $3 for the channels above 30. So I'm going to do X minus 30. I'm going to take those channels away because they're already paid for here in the $65. And then this is for X, number of channels, greater than 30. And that is the answer right here. That's your piecewise defined function. So you try number 2 and check it with the key. All right, next learning target. I can graph a piecewise defined function. So we're given this function right here. This is our piecewise defined function, and I see I have 3 pieces here, so there's going to be 3 graphs, all graphed on the same coordinate plane. So I'm just going to draw this out real quick. Okay, so to graph this, the first thing I want to do is determine the x values. Determine the x values. Okay, so let's look at the problem. I'm looking for x values. Here are my x values given in the domain. So -4 and -1. -1, 3, 3, 6. Okay, those are my x values. Now I want to take all these x values and plug it into the equation it belongs to. Plug in x values. And what this is going to do is it's going to give us our endpoints. So plug in x values to find endpoints, and I'll show you what that means right now. So I'm going to plug in -4, sorry. I'm going to plug in -1 into this equation. Now there's no x in this equation, it's just a constant, so that means my y value is just that number, that constant number of 7. Now I'm going to plot these points. And I'm going to look to see if it's less than, there's no, or equal to, there's no line underneath it, then your point is open. It's an open circle. Open circle. If it does have that or equal to, then it is a closed circle. So these are both open circles. So -4 is 7. 4, 5, 6, 7. Okay. So 4, 7. And then -1, 7. And it's just a constant, so that means it goes straight across. So after you have your 2 points, you just draw your graph. In this case, this problem, the 7 is a constant, so our graph is just a straight line straight across there. Okay, then we'll go back to step 1 here, determine the x values for my next piece. Now I'm on the x minus 4 piece. So my x value is -1, plug it in. So that's -1 minus 4, which is -5. So that's my first point. My next x value is 3. Plug that in. So 3 minus 4 gives me -1, and that's my second point. And again, they're both open. -1, -5. And then 3, -1. Now I need to draw my graph. So I'll go back. This is x minus 4. I know the parent function of When it's just an x, that's a linear. It's a linear function, so that's just a straight line. Okay, next one. Determine your x values. So I have 3 and 6. Okay, so I'm going to start with 3. I'm going to plug it in. -2 times 3 is -6. Plus 6 is 0. So I have the 0.30. Then my next value is 6. I'm going to plug that in. -2 times 6 is -12. -12 plus 6 is -6. And then I'll plot those, both open again. So 30 and 6, -6. Go back and check, that's a linear. Again, it's at mx plus b form, so it's a linear, so just straight line. Okay. So now you can try number 4 on your own and then check it with the key. So skipping down to 5, I can write the rule that defines a piecewise defined function. So this one's going backwards. We're given the graph, and now we have to write the function. We have to write the equation here. So kind of opposite of what we just did. So let's look at letter A here. So the first thing you want to do, well, I always number them 1, so I know what I'm doing here, 1, 2, 3. So I have 3 pieces, so that means I'm going to have 3 equations with 3 domains here, domain for each. So the easy part usually is finding the domain, so I'm going to start with that. Find the domain using x values. Okay, so let's start with number 1 here. Number 1, these are going by 2s, 2, 4, 6. And that's in between there. So that's at -5. This is -5 here. And then it's going to -2 here. And they're both closed, so that's going to get the less than or equal to there. So -5 less than or equal to x, less than or equal to -2. Okay, so I have my domain. Now I want to determine what is the parent function of this graph. So determine parent function of the graph. So graph number 1 is just a straight line straight across. So I know that's a constant. I know that's a constant. So if you have a constant, like we do here, then we just need to find the y value. And then that is your equation. So the y value here is at 7. So my answer is just 7. And then my domain, of course. All right, let's try another one. Let's try number 2 here. So I want to find my domain using the x values. So that's -2 to 3. And then I'm going to determine my parent function. My parent function here is, it's a linear, it's a straight line. So it's going to fall into that y equals mx plus b. So if linear, like we have here, if linear, you need to find the slope. That would be your m. And you need to find the y-intercept. And that would be your b, and then you're going to put it in that y equals mx plus b would be your answer there. All right, so let's do that. I know it's linear, so I'm going to determine the slope. It's going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So my slope is -1. And then the b is right here at 5. So I'll put that together, and my answer would be -1x plus 5, or just -x plus 5. So that would be the equation with that domain there. Okay, number 3 is also linear. It's also linear, it's a straight line. So when I have a linear, I need to find my slope and my y-intercept, my m and my b. So the slope here is up 2 over 1, up 2 over 1, so +2. And then if I keep reversing it the other way, over 1, down 2, over 1, down 2, over 1, down 2, over 1, I see that it ends at -3. So I'll put that together, 2x minus 3, and then the domain is from 4 to 6. That one's open, so it's just a less than. Okay, and then I can put it all together. So after I have all this figured out, I'm going to write it as f of x equals, with a fancy bracket, and then I'll put it all in there with the domains. Okay, so it looks like this. F of x equals, and then I put my first one, and then my second, and my last one. Okay. And then this would be your answer right here. So now you get to try B and check it with the answer. Keep posted. Okay, going on. Moving on, next learning target. I can use a step function to model a real-life situation. Step function, that's the graph that looks like the little staircase. So let's go over that. Here is my piecewise function there. And remember, the step function is a special type of piecewise function. It still is broken up into pieces that when you graph it, it's going to make that step, that staircase. So the first thing you want to do is to determine your x and y values. So let's read through the problem and try to figure out what are my x and y values. So Mrs. Oskey's room can seat up to 30 students for each class period. On a separate sheet of paper, draw a graph that represents this situation. We're just going to draw it right here. But it says that the number of students is x and the number of class periods is y. So those are my x and y values there. So when I go to graph it, my x-axis will be my number of students, and my y-axis will be my class periods. Okay? So here's my class periods, 1, 2, 3, 4, so that would be my y. And here's my number of students here. These are my x's. Okay, so in class period 1, 2, 3, 4, and then here, I'm going to do these by, so this is going to be 1, 2, 3, 4, and I'm going to do these by 30s because I don't want to draw all those little lines. 90, 120, 150. Okay, so now I can go ahead and graph it. So my x value to start is 0, 1. So the point 0, 1, and then the point 31. Remember this, these are the x's, these are the y's. So I've got my x and y determined. Now I'm ready to plot the points. And it's going to be open for the less than and closed for less than or equal to there. So at 0, 1, that's open. And then at 31, that's closed. And then finally, x is all the numbers in between 0 and 30, so we have to show that by connecting them. So go ahead and connect to make that step. Okay, so let's try this one. So this would be 32, and then the point 62. Open and then closed, and then connect them. And then you keep going from there. So 63, open, 93 closed, connect. And then the last one, 94, 124 closed, connect. And that would be your step graph. So now we want to give domain and range. So remember, domain are your x values going left to right. So x value starts at 0. This is the point 0 here. And then ends at 120. And notice that it's open at 0, so that's going to get a parenthesis. And then it's closed at 120, so that will get our bracket. You could also write it in set builder if you'd wish. That would look like this, x such that 0 less than x less than or equal to 120. Either one is acceptable. And then range is your y values, so going from the bottom to the top. But see how we have these little disconnects here. So it's at 1, but then there's nothing in between, no y values in between 1 and 2. My next y value is 2. No y values in between 2 and 3. My next y value is 3. Same thing, next y value is 4. So my range looks like this. I have y value of 1, closed, 2, 3, and 4. 2, remember that means union, so that's all these intervals together. 1, 2, 3, 4. Or set builder would look like this. Y equals 1, 2, 3, 4. Okay. So now you have a chance to try number 7. And check it with the key. Right, going on to section 1.5. I can solve equations and inequalities by graphing. So this is when you need either your graphing calculator or the Desmos program that we learned how to use on Friday. One typo here I need to fix. Cross out this 4 here. Do not do that. Will not work out. Cross out that 4. Okay, so if whatever you're using, Desmos or your graphing calculator, you're going to graph each side of this equation separately, but keeping it on the same coordinate plane. Graph each side separately. So you're going to graph the absolute value of x plus 2, and then your next y equals, or your next box in Desmos would be the x plus 1 squared. Graph each side of equation separately but on the same coordinate plane. All right, so go ahead and throw that in to whatever program you're using. I'm just going to draw a sketch of it, so you should have an accurate picture in front of you. But the absolute value of x plus 2 would be over here at 2, at negative 2 here. And then x plus 1 would be over here. So something like that, okay? Again, this is just a rough sketch. But you see you have two intersections, one here and one here. So this first intersection here is the point negative 1.64, and then this intersection here is the point 0.6 to 0.6. Oh, kind of jumped ahead here. So that was step 2. Step 2 is to find the intersections. So those were the two intersections. So after you graph it, you locate the intersections, and then you write your answer as an ordered pair. Okay. Let's go ahead and jump ahead. So you can try number 9. Number 9 is like that one. So I'm going to skip down to 10 because that's an inequality. So for inequalities, so what we just did was an equation. Let's go back and clarify that a little bit. What we just did was an equation because it's an equal sign here. Equal sign. So this is equation success criteria. And then what we're doing now is an inequality. And we know that because it has an inequality sign in the problem. Inequality success criteria. Okay, so just like what we did before, we still want to graph each side separately on the same plane. Okay. So we'd go ahead and you would put in, oh, another typo here, I'm sorry. You have to change this +4 to -4. Change that +4 to -4. That's all the typos. That's it. Okay. So I'm going to put in this in my first Desmos box or in my first y equals in the graphing calculator. And then this would be my second equation. And remember in Desmos, to do a constant, it requires an x, so you have to do 0x plus whatever that constant is. So in this problem, it would be 0x plus 0 would go in your second box there. So I'm going to graph that. Let me just show you the sketch. So in front of you, you should have the accurate graph. Looks something like this. Okay. And then your 0 was just the x-axis here. Okay. And then here would be your two intersections. Oh, jumped ahead again. That's step 2. Find the intersections. Okay, so now this is where it gets different with inequalities. After you find the intersection, you have to determine if you're looking for positive or negative. So you go back to the inequality sign, and this is a greater than, so our problem we're looking for the positive. So if greater than or equal to, then positive. And for positive, you're looking above the intersections. So in this problem, here's my intersections. I'm looking above those intersections. So here and here. Okay, so I'm going to highlight those intersections there. And then if we had negative or, not negative, sorry, if we had less than or equal to, then negative, then we're looking for what's below the intersections. And that is found by looking at your problem. So I know it was a greater than. So greater than is positive. Positive, you look above. So I'm looking above those intersections. And I highlighted that. So highlight, then draw your arrows to show direction. Okay, so I'll look at this highlighted piece. My arrow would go this way because it's going closer and closer to negative infinity. So this is going towards negative infinity on the x and the x values. And then this one is going towards positive infinity on the x values. So now I'm ready to write my answer. And I'm going to write my answer as an inequality. As an inequality using x values. All right, so my x value here from my intersection, I found this was -5. And then the x value here is -1. So I'm ready to write my answer. So this piece is -5 or less because it's going towards negative infinity. The x values are getting smaller as you go this way. So that would be x less than or equal to -5. And I get that or equal to because the problem is or equal to up here. Or it could be this one over here. I'm going from -1 to positive infinity. It's going this direction towards positive infinity. That means my values of x are getting bigger. They're greater than -1. So x greater than or equal to -1. All right, then you have a few more to practice there. So you can do those and then check with the answer key. All right, last learning target. I can use an inequality to solve a real-world problem. So another story problem here. So first thing you want to do is obviously read it. And then I want to highlight each case separately. So let's try that. AJ begins his summer with a savings of $100 more than Nadia. AJ's job pays $8.25 per hour, and Nadia's job pays $9.50 per hour. If they both work the same amount of time each day, how many hours of work will it take Nadia to have as much money as AJ? Write an inequality and solve. All right, so I have two cases. I have AJ's case and Nadia's case. So let's talk about AJ. AJ has a savings of $100 more than Nadia. So So he's up 100 there. And then his job pays $8.25 an hour. And then my second case is Nadia. So Nadia's job pays $9.50 per hour. So she makes a little more than AJ, but she just doesn't have that extra $100 like he does. And we want to figure out how long is it going to take Nadia to have as much money or more money than AJ. So now after I've highlighted my important pieces of information here, I'm going to go back and determine what is X? What is my unknown? Determine what is X. So the variable in this problem is the number of hours. That's what we don't know. We don't know how, that's what we're trying to figure out. How many hours of work will it take? So our X in this case is the number of hours. Okay? Now we're ready to write our equation. So we're going to write an expression for each case. So we're going to write an expression for AJ, and we're going to write an expression for Nadia. Write an expression for each case. Okay, so let's look at AJ. So he has $100 more than, $100 more than Nadia, and then he makes $8.25 per hour, $8.25 times the number of hours he works. And then Nadia makes $9.50 per hour, or $9.50 times the number of hours she works. Now we need to determine the inequality sign. Determine the inequality sign. And then finally solve for X. Okay, so let's look back here. We want to know how long or how many hours it's going to take for Nadia to have as much money or more money than AJ. So Nadia needs more money or the same amount. So that's that sign there showing that Nadia wants more money. And then we'll just solve the problem here. So I'll subtract my $8.25x from each side so I can get my x's together. And then finally, to get x by itself, I'd divide by the 125. And then you get 80. So Nadia has to work at least 80 hours to catch up to AJ. All right. So you try the next one and then check it with the answer key. Good luck on your quiz.